How animals sense earthquakes before they happen. Earthquakes strike suddenly, often without any warning. Buildings shake, the ground shifts, and lives can change in an instant. Yet throughout history, one recurring observation has sparked curiosity and scientific debate. Animals often behave strangely before earthquakes occur. Dogs may bark or hide without reason, birds may flee their nesting areas, and fish may behave erratically long before humans feel the slightest tremor. While humans rely heavily on instruments to detect seismic activity, many animals seem to possess an instinctive awareness of something happening beneath the Earth's surface. This raises a fascinating question. Do animals have the ability to sense earthquakes before they happen? And if so, how? This video explores the historical accounts, scientific research, and potential biological reasons behind this phenomenon, and discusses how animal behavior could influence the future of earthquake detection. Historical observations and cultural beliefs. The idea that animals can sense earthquakes long predates modern science. Ancient civilizations closely observed nature and often depended on it for survival. In several cultures, animals were believed to act as messengers, creatures capable of detecting unseen dangers. Ancient Greece. One of the most famous historical accounts comes from Greece in 373 BC. In the days before the city of Hellas was destroyed by an earthquake and tsunami, residents noted that rats, snakes, weasels, and centipedes fled the city in great numbers. The people did not recognize the significance of this event at the time, but the observation was recorded and passed down as part of natural history. China's earthquake traditions. For centuries, the Chinese paid close attention to animal behavior for signs of natural disasters. Farmers reportedly watched their livestock closely, believing changes in their temperament or routine could warn of danger. Dogs, chickens, and horses in particular were thought to be especially sensitive. Modern accounts. In 2004, just before the devastating Indian Ocean earthquake and tsunami, locals in Thailand observed elephants moving inland away from the coast. Similarly, flamingos abandoned their low-lying nesting grounds shortly before the disaster struck. Zoo animals in many regions refused to come out of their shelters, as if sensing something unusual. These recurring patterns across time and geography suggest a consistent link between changes in animal behavior and seismic events. Scientific investigation into the phenomenon. For many years, scientists were skeptical of claims that animals could sense earthquakes. Much of the evidence was anecdotal, lacking systematic observation or controlled conditions. However, as technology has advanced, researchers have been able to gather more reliable data. Today, some scientists attach motion sensors to farm animals such as cows, dogs, goats, and sheep in earthquake-prone regions. These sensors continuously monitor activity levels, movement patterns, rest cycles, and group clustering. When this data is compared to recorded seismic activity, interesting patterns sometimes emerge. Increased restlessness before earthquakes. In several studies, animals showed noticeably increased movement and agitation hours before an earthquake. They paced, clustered tightly together, or acted as though trying to escape confinement. While not every earthquake produced these responses and not all animals reacted, the correlation was strong enough to be statistically meaningful in certain cases. Distance matters. In some research, animals closer to the earthquake's epicenter showed unusual behavior earlier than those farther away. This supports the idea that animals are responding to subtle environmental signals emanating from the ground itself. Not all studies agree. It is important to note that scientific consensus has not been reached. Some studies failed to find clear correlations, and animal behavior can vary widely for reasons unrelated to earthquakes. Still, the growing body of controlled research provides compelling reasons to continue exploring this field. How animals might sense. Earthquake scientists have proposed several possible explanations for why animals might detect earthquakes before humans can. The most likely explanation is that animals possess sensory abilities that are more finely tuned to environmental changes. 1. Detection of subtle ground. Vibrations earthquakes do not begin with the dramatic shaking that humans notice. They start with weak P waves, fast-moving seismic waves that travel through the Earth before the stronger, destructive S waves arrive. Most humans cannot feel these early vibrations, but animals may detect them through highly sensitive internal sensors or through the structure of their feet and bones. For example, animals with whiskers may sense tiny movements in the air or ground. Hoofed animals may detect vibrations through the ground surface more efficiently. Burrowing animals may feel shifts in soil density sooner than surface-dwelling animals. Even a few seconds of warning can trigger alarm behavior. 2. Sensitivity to sound. Frequencies beyond human hearing. Earth movements can produce infrasound, sound waves below the human auditory range. Birds, elephants, whales, and many other animals can hear infrasound. If seismic shifting produces low-frequency vibrations, animals may detect them much earlier than humans. 3. Detection of electromagnetic changes. Before an earthquake, rocks under pressure can release charged particles or alter the Earth's magnetic field. Many animals, especially migratory species, navigate using the magnetic field. If that field fluctuates, animals may become disoriented or distressed. This could explain sudden flight behavior or herd clustering. 4. Chemical signals and gas release. Small cracks in underground rock may release gases or alter water chemistry before an earthquake. Animals that rely on water or moisture, including frogs, toads, and fish, may detect these changes quickly. This may be why amphibians in some regions stop breeding or leave ponds before a quake. 5. Group response and emotional contagion. In group-living animals, one individual reacting to a perceived threat can cause the entire group to panic. So, even if only a few animals detect the environmental cue, the behavior spreads rapidly. Different animals respond to environmental changes in different ways, and these reactions can sometimes appear before an earthquake occurs. Dogs and cats, for example, may begin to behave anxiously for no clear reason. They might hide, shake, bark excessively, or become unusually clingy toward their owners. Birds are often seen leaving their nests in large flocks or becoming strangely silent, as though startled by a sudden threat. Horses and other livestock may pace nervously, refuse to enter barns or shelters, or crowd together tightly for protection. In the water, fish may swim erratically, leap from the surface, or gather unusually close to one another. Meanwhile, insects sometimes disappear or swarm in patterns that differ from their normal activity. Reptiles and amphibians, such as snakes, frogs, and toads, may leave their burrows or interrupt seasonal behaviors like breeding or hibernation. While these reactions are frequently reported before earthquakes, it is important to note that they are not exclusive to seismic events. Animals often respond to a variety of environmental cues, so scientists remain cautious when interpreting these behaviors as direct predictors of earthquakes. Limitations and challenges in using animals as predictors. Even though many examples support the idea that animals detect earthquakes, there are major challenges in relying on animal behavior as a prediction system. 1. Not all animals react before every earthquake. 2. Animals may react to many unrelated stimuli, such as predators, storms, electromagnetic equipment, or human disturbances. 3. The timing is inconsistent. Some changes occur minutes before, others days before. 4. Behavior is subjective to interpret. What looks unusual can vary widely. 5. There is no standardized measurement system across species or environments. For these reasons, animal behavior alone cannot currently replace scientific seismic monitoring. Combining technology and animal behavior. As monitoring devices become more precise, scientists are exploring how to merge animal behavior data with traditional earthquake detection tools. Smart collars, GPS trackers, motion cameras, and heart rate monitors can collect continuous data from herds or flocks. This data can be analyzed with computer algorithms to look for patterns that may indicate seismic activity. One possibility is a global animal-based early warning network, where farms, sanctuaries, and even pets contribute to a shared detection system. If technology can accurately identify patterns in animal response, society may one day receive alerts hours before a quake occurs. This approach is still in development, but it offers a promising direction that blends natural instinct with scientific innovation. Conclusion: animals may not predict earthquakes in the human sense, but they can detect subtle environmental changes long before humans or machines are aware of danger. Their heightened senses, whether attuned to vibrations, infrasound, chemical changes, or electromagnetic shifts, allow them to perceive the Earth's movements in ways we cannot. While animal behavior alone cannot yet serve as a reliable earthquake warning system, ongoing research continues to strengthen the connection between animal sensitivity and seismic activity. By combining scientific instruments with natural biological awareness, we may one day harness this ability to save lives. For now, when animals behave oddly, especially many animals at once, it may be worth paying attention. Nature often speaks before the Earth does. If you found this video interesting and would like to learn more about the incredible abilities of animals in the natural world, make sure to like this video and subscribe to the channel. Your support helps us continue creating more educational and eye-opening content. Don't forget to turn on notifications so you never miss a new upload. Thanks for watching, and stay curious.